Okay, so I wanted to do a little explanation video of, this is not garden related, this is something else I've been kind of thinking about. And I call it the LoXiTron. Now, I know this example is very rudimentary and I don't care. I'm not trying to impress anybody. But this is how it works. So the LoXiTron is a fueling system. It's like a helicopter, like a drone ship. And it's used for fueling, in-flight fueling of rockets. So in this example, I decided to use a Starship because that's a little more exciting than some of them. Okay. So here's the Starship, fully loaded with its 150-ton payload. So that's the example I used. And Grok helped me do some calculating. It's actually kind of fun. That was part of the thing. So in this case, the payload is LOX, right? So here's the second stage, and it's 150 tons of LOX. That's, you know, like it's one of the things that you've read, right? I'm sure that, you know, there's a lot of wiggle room in there too, but... So what happens with the LoXiTron is we want to maximize payload to orbit in terms of LOX. This is the LoXiTron. Okay, imagine that. That's your drone ship. And the LoXiTron was visioned to work with different cryogens. It could be kerosene, it could be water, it could be hydrogen. So getting more payload to orbit seems to be the thing, and a lot of ways to do that is slimming mass, better rocket engines. There's all kinds of ways. Boosters, you know, you could have boosters to the side, right? We've seen that. So now the LoXiTron was also intended to be rapidly reusable. See, and that's the thing that everyone likes to do these days. So here's the LoXiTron. Now I got 600 tons, 5, 6, 700, whatever works, of LOX. Now I choose LOX because that's the biggest portion of propellant used in rockets. So this is what happens. Now, well, I'll show you what happens. What happens is the LoXiTron, T-minus 10, comes up and it hovers above the Starship. And it's connected with a hose. Now this hose is going to have to be engineered to be flexible and, you know, usable. But both these ships have to accelerate exactly at the same rate. And that's not going to be hard. That's going to be pretty easy, right? You know, maybe you have to develop rockets that are extremely sensitive to throttle differences, adjustments, you know. So as the rocket's taking off, the LoXiTron is going to transfer LOX into the second stage. Okay? Now this is happening pretty quickly. This is happening, I figured you'd get maybe 30 seconds, something like that, near the higher end. It could go more, but we'll see. So it's transferring LOX into the second stage. So all this is happening before stage separation. It's probably happening before max Q. Okay, so why this increases your payload is because here you go. Now, I want to get more payload to orbit. Okay, in terms of just raw LOX. But now I got 600 tons of my propellant coming out of the main booster. Okay, you got to remember I just made the whole thing 600 tons later. Now I have to recalculate all the calculations in terms of propellant use, right? Now I reduce the propellant in the actual booster stage because I'm 600 tons lighter. So now what happens, okay? Now my takeoff weight is 600 tons lighter plus a recalculation on booster propellant because now we're lifting a whole lot less. Now what happens with the LoXiTron is, don't quote me on exact math. It's going to be very, touch and go. There's going to be a whole different. The extents of this can be plus or minus. There's going to be quite a range. So as the rocket's taking off, the LoXiTron is filling the second stage at the rate of use of the booster in total mass. Not separating it, it's just methane and LOX, the total mass used. So at the rate of use, the LoXiTron is filling up the Starship booster. Okay? This is what's happening over the course of, this is whatever works best. You see what I'm saying? Because we want to get as much of this shit into orbit as we can. So, over the course of 20, 30, 40, 50 seconds, I don't know how far the technology will go. You just increased. Now, the reason this happens is because your takeoff weight dropped by 600 tons, 700 tons, maybe 1,000 tons. It's hard to say how far you could really take this because it hasn't been done. It probably has never even been conceived of. If it was conceived of, it should have been happened. And I know why that is, but I'll get into that some other time. So, because I externalized 600 tons of the booster's propellant, right? It's kind of like a swapperoo here. The LoXiTron is carrying 600 tons. So the dynamics of the whole Starship change, right? You don't have to be at full throttle. On takeoff, you probably want to throttle back a bit. You got max Q, there's different things, but it's transferring fluid up here. You see? It's going to fly at the same trajectory, right, as the Starship. And it's going to be filling, I should say, the Starship, which is intended to be, the whole idea was orbital gas stations or gas stations. You need freaking gas stations no matter which way you go, even if it's nuclear, you need gas stations. So the LoXiTron is taking a huge amount of that weight right off the takeoff weight. Now that could be, it's going to go, right? So, because your takeoff weight is lighter, you have to recalculate the fuel with the new scenario. Now it's being transferred at the rate of use of mass, right? Mass used, mass transferred. So you're basically, your takeoff weight stays the same for like 30 seconds. Or maybe plus just a little, like it might be better to add just a little bit, right? Because you want to get as much payload in orbit as possible. So that's how it works. The LoXiTron hovers above the Starship. And we do this with planes, right? But we're just going vertical with planes. As a matter of fact, I think this would be easier once you get things sorted out. It just transfers into the second stage. Now you could transfer it into the booster, right? But at the end of the day, it's about getting more LOX into orbit. That's the whole point of it, or cryogenics. You could develop a system if you wanted to get, if you wanted to pipe it down here, or something like that, but that's kind of not what I intended. But that's how it works. You externalize 600, 700 tons, 5, whatever you want, right? 300, 400, 500 tons. It'll work for just about any orbital rocket. And that's how it works. Right? As it goes up, it transfers it down. The propellant in the main booster has to be reduced. And your payload gain is basically something like that. You have a huge payload gain. If the math works out, Grok did most of it, so there you go.